So the review of factoring that we've done on the past few videos are leading us up to actually solving a quadratic equation. So this section is not going to take us long because we've done all the legwork of what's going to be utilized here. Three things. How are quadratics solved? By factoring. That's going to be a very short review. What is the square root property and how is it used to solve equations? And then what is the quadratic formula and how do we use that to solve equations? So according to the zero factor property, if we have two factors multiplied together, in order for their product to be zero, either one or both of them must be zero. That's what we use when we solve a quadratic using factoring. So the first example that you see here is a quadratic that's already in factored form. So using that zero property, I know that either x plus 14 equals 0 or x minus 14 equals 0. Or it might be both. In the first case, x would equal negative 14. And in the second case, x would equal positive 14. So there are two solutions. The second example here is not factored yet. This is factored with a GCF. So I have two factors, x and x minus 2. So I'm going to set each of those factors equal to 0. I'm going to let x equal 0 and x minus 2 equals 0. What's nice about this first one is that that's done. For the second one, I would add 2 to both sides, and the second solution is x equals 2. The other way to solve a quadratic equation is using the quadratic formula. This method always works, so if you are not real good at factoring or just haven't gotten quite comfortable yet with it, you can always use the quadratic formula and it'll solve any quadratic equation. You have to put the quadratic equation into standard form, and then you have to figure out the values of a, b, and c. This is going back to the standard form being ax squared plus bx plus c equaling 0. So let's look at the first example. I'm always going to check to see if it can be factored, especially if the leading coefficient is a 1, because that's going to take a whole lot less time. So here, leading coefficient is a 1, so I'm looking for two numbers that multiply to 42, but add and give me 13. Well, that's 7 and 6. So this factors to b plus 7, b plus 6. Set each of those equal to 0. So set b plus 7 equal to 0 and b plus 6 equal to 0. In this case, b equals negative 7, and in this case, b equals negative 6. Two solutions. Now when you go to do this one, if I multiply the first and the third term, I get a pretty big number. So this may be an instance where the quadratic formula is better. So I'm going to go ahead and write that formula out. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So I've got here a, b, and c. So the opposite of b is negative 11 plus or minus the square root of 11 squared is 121 minus 4, a is 6, c is negative 35, all divided by 2 times 6, and we know that that's 12. So I'm going to go ahead and cross that out. We'll make that a 12 from the beginning. Next step, negative 11 plus or minus the square root of, now I've got 121 minus, and when I multiply these three terms together, I get negative 840. All over 12. So that's 121 plus 840, that's 961. And the square root of 961 is 31. So let's go ahead and add another slide. So recall we've got negative 11 plus or minus the square root of 961 all over 12. And the square root of 961 we said was 31. So this means, this plus or minus sign means there's two things we have to do. The first thing is to add 31 and simplify that. So that gives us 20 over 12, which can be reduced, both of those divisible by 4, to 5/3. The second thing we have to do is subtract it. So that's going to give us negative 42 over 12. Those are both divisible by 6, so that's negative 7 halves. Sometimes you may need to rearrange some things first. So in this case, I've got to move the 1 over. And then I can decide quadratic formula or should I factor? Well, let's see. That gives me a negative 6r squared. Are there two numbers that I can multiply that give me negative 6 that add to 1? Well, that's 3 and negative 2. So I'm probably going to go through and factor that because that's going to take just as much time as the quadratic formula. The second example that you see, r minus 2 squared equals 7, I want you to realize if you have one whole entire term squared, take the square root of each side. Don't even worry about quadratic formula or factoring it. If you take the square root of the left side and the square root of the right side, on the left side you'd end up with just r minus 2, and on the right-hand side you have positive or negative square root of 7. Because remember, if you take a square root, it could have been positive or negative. So then you would add 2 to both sides. So r is equal to 2 plus or minus the square root of 7. And guys, there are going to be instances in MyLabs Plus when it asks for answers in radical form. So you're going to need to be comfortable looking at something and saying, you know what? Doesn't make sense to factor it or use quadratic formula. I'm going to take the square root of each side. Finally, the last piece that I want to define for you from this section is a piece of the quadratic formula called the discriminant. And that piece is the b squared minus 4ac piece. And if you recall, that's the piece that's typically underneath of that square root sign. So a couple things. If b squared minus 4ac ends up being a positive number, then we know that the number of solutions for that particular quadratic is 2. If b squared minus 4ac ends up being a negative number, then there are 0 solutions that are real numbers, that aren't imaginary. Finally, if b squared minus 4ac is 0, then there's one real solution. So now I want you to go ahead and practice this.